A very good evening to everyone. My name is Pragya Sharma, and I'm here to introduce our esteemed scholar and speaker for today's session at Council of Policy Research, Rajasthan. Dr. Aijaz Ahmed holds a PhD in sociology from Aligarh Muslim University and is currently serving as an ICSSR Postdoctoral Fellow at Jawaharlal Nehru University. He has published several research papers and authored over 21 undergraduate level books in sociology. His expertise lies in medical sociology, chronic diseases, and research methodology. He also contributes to social impact through NGO work and academic engagement. We welcome you, sir, and over to you.
Thank you very much, especially the CAP Rajasthan, who actually have taken this kind of initiative for enlighten the scholars, particularly from very humble background. So I'm very thankful to the Vishnu. I think Vishnu is there. So and all his team member are his organization members. Thank you. Our topic, today's topic is like sampling. So before directly jumping toward the sampling and directly understanding what are the types and how actually we use different types of sampling, we just go in a proper way. So before jumping to the types are the things which we have available in many books. We have many books actually through which we can even understand and we can read what is the sampling and why we need the sampling actually. But here I will just try to scrutinize and conceptualize in a very practical way. What are the sampling? Why we need, basically the first question is, why sampling is needed? And where does probability sampling belong? The two questions, and I will just try to basically revolve around the whole discussions of today's lecture on these two kind of questions. So the thing which we must inculcate, that what is the basically the sampling? Why we are just talking about the just 1 minute. So when we're talking about the sampling, one thing we must remember, that what is the sampling first. So sampling involves the selecting a small number of representative units from an entire domain or entire population. We study them in depth to reach conclusion generalized for the whole population instead of investigating every single unit. So before actually we try to understand, like here you will see when we actually go to the doctor, and we try that doctors actually try, if they actually we have any kind of infections and any kind of problems in our blood, doctor never ask us to give us the to take the blood off from our entire body, but instead of that they actually took a very small drop of blood. So the small drop of blood is basically a sample which represent our whole body's blood, because blood is blood. We don't need to take blood from here and from here and from head and from nose and from shoulder and from thighs. But instead of that, doctors actually take the blood from particularly from hands or from arms, and the blood is basically represent our whole body. So whole body is our population. Through this example, I just basically try to make you understand. Like from the whole body is like a population, and a little drop of blood is a sample. The sample which represents our whole body. If a sample is have some kind of infections, so it denotes that our whole body's blood is not going well. It has certain kind of infections. So similarly, sampling is very, very important when we try to actually study the population. When we try to study a very known kind of population, a very broad kind of population, so in such kind of circumstances, we need a sampling size. We need a sample, because on the whole population, we can't actually take the whole population into considerations. If you can, look here, what exactly the sampling means. So here is a quote. I'm just trying to show that a cart loaded of coal is accepted or rejected on the basis of evidence. Evidence is gained from testing only a few pounds. So physician, like here you will find, physician make interference about a patient's blood through examination of a single drop. So it means that a single drop of blood actually represents the patient's whole body. So similarly, when we actually try to study any kind of area, any kind of population, we are not in a position to take the whole population into considerations. So instead of that, we take a sample, which we actually try to operationalize in the next slide. So the sample is basically what exactly sampling means and why actually we use, because it reduces time, cost and efforts. Because if anybody is studying Rajasthan, any village, so suppose there are 10,000 or 20,000 or 20 lakhs people who are actually residing in particular village. So it's not possible to take the whole village population into considerations. So out of the whole population, what a researcher can do, took a sample. So how actually they took the sample, how actually they take the sample, we will discuss in later slide. So another things, what will be the ideal sample versus potential error? Two important things we must inculcate while we are choosing any kind of sample. One thing, there are some characteristics of ideal sample. Like we have seen, if just I'm giving you an example, like if you are choosing, somebody has told you that who is your model? Who is your model teacher and who is your model? And you actually, many students says that, yeah, this A is our model, B is our model teacher, C is, but on the basis of which? So we sometimes the intelligent students or the intelligent mind actually try to create certain kind of features in their mind. On the basis of that, they choose model teacher. But some people are there who actually choose model teacher on the basis of they are polite, they are they are polite, and they are giving high marks. But these we can call, these are also characteristics features. But the difference is that some are making a very solid kind of feature, and some are making very layman kind of feature, but both are making the feature on the basis of it they decide that this is our model teacher. Similarly, there are some kind of what we should say qualities or features of an ideal sample. So what are these features? The foremost feature is representation. The unit you actually selecting, the village people you actually going to research. The one thing you must inculcate, that there will be, the selected unit must be representative, which actually represent the whole data or whole population. Like if you are selecting the like Rajasthan, how many women are basically doing vendors work. You are getting me? So your goal is to examine the women empowerment or women migrations. So you must choose the people who actually migrate and have certain kind of association with vendor kind of works. You are getting me? If you are not selecting the particular based on your particular objective, so it means you are not selecting an ideal kind of sample, and it creates like an error when you are trying to make an analysis. So another thing, the second important, what I should say, the feature is independent. Every unit must have fair chance to be included. Unit are interchangeable. So every unit have fair chance of selections. So how we can justify it, and how we actually know that the things which we are going to select is a very fair, because based on certain kind of literature. Because the in next slide I will actually show you that which and where actually the probability sampling belong. So there I will tell you that how you can analyze that we can choose a very fair kind of fair chance of, are we giving the fair chance of selection to each and every unit. Adequate means the sample size must be sufficient to confidently infer the population result. Suppose if we are selecting the women, we must select the size, the population size. It's not like we are selecting 10 women and we are selecting 10 women or 15 women, but women who are not have some kind of associations with like vendors, but only we selecting women who have certain kind of shops. But there is a difference between shops and vendor, street vendor. And if we are not selecting properly, if we selecting the women who are doing like shops, so it means we are straying from the righteous path. We are not going in a right direction while selecting or choosing the sample. So homogeneity and homogeneous population is a very important feature while selecting the sample. Like sampling unit must share foundational characteristics to remain scientific, like women and women. Because if our objective is women, to examine the upliftment, to examine the behavior of the street vendor women, so we must select only women, not men. So if we are selecting men, it means they are not homogeneous. And in women, if we are selecting women, but who women actually, those who have street vendors, then we are going in a right directions. So what are the errors in while selecting the sampling techniques? First things, accuracy. Accuracy is very important. Naturally has more fault compared to a 100% census. So if your sample is not going in a particular direction, like if you have 500 women who actually have doing street vendor kind of business, so you first take the 5% out of 500. So what are the exact number you should try to calculate? Like 5%, if I will take the 5% out of 500, so what will be the that 5%? You took the particular number. If you are not taking the numbers, then it means that you are not going toward a particular, and your accuracy will not be maintained. Changeability is very important. If unit change dynamically, so extending result to the whole become unscientific. So dynamically means if your unit is basically dynamic, like changeable, so extended results to the whole population become unscientific. So if sometime you are choosing 5%, sometimes you're choosing 6%, so you don't need to make a dynamic kind of decision while selecting any kind of unit, but make a fix. 5% is 5%. 6% and 6%. If you are making a change, it means your result will not be scientific, but unscientific is basically. So false conclusion. So selecting only well-off student to gauge general food expense yield misleading data. Like suppose I'm just giving you here an example that if we are trying to understand the food habits or the food expense of the people who have living in universities, in outside universities or in hostels. So if we our purpose is like who afford the food, street food. So if you are selecting only some well-off people who have money and easily can make a very general kind of expense on the food, so it means that we are misleading data. So what exactly we are trying to do? We are trying to select our population, our student based on our objective. So expertise barriers, highly dependent on the skill of the researcher to prevent bias. So these are some basically the potential errors and ideal sample characteristics which we must inculcate while we are selecting the sample. So before going to select the sample, we must actually construct these kind of things in a very explicit way. So this will help us in when we going into the field and selecting certain kind of sample. Sorry. So some characteristics and when to use these kind of sampling. So why we use and when we use. Like the first thing, why we use the sampling. First thing is cost and time. I have earlier told you that if you are selecting a village in Rajasthan which have particularly 5 lakh of populations, so how much time you need to go each and every person and collect the data? How much time and cost you have need? Cost means your travel expense, your eat like your food and anything you can include in this. And time, how much time you have need to reach each and everybody door and just collect the data. So the sampling is helping us to minimize the cost and time. So basically this like significantly reduce expenditure and time compared to full census. So instead of doing the full census, we just took the sample. Like I'm giving the example in the first slide that how basically a doctor and physicians took a small drop of water from our body. On the basis of that, they actually generalize the whole our whole body, then what are the infections or blood health. So highly suitable when dealing with large or infinite data size. So it is very important when you are selecting a very huge kind of data. So at that time you have to need to select the sample. So reliability and depth. So it's very important that if you choose carefully, if you choose sampling carefully, sample yields result as reliable as a census, while allowing in-depth, multifaceted observations of fewer units. So if you are selecting carefully to the sample, like I'm giving you the example of your like village, any kind of village you are going to study, so you must be careful that what are the populations of that particular village, how many households are there, and what are the total populations, and the not populations. You don't what are you are selecting which kind of populations. You are selecting marginalized kind of population, you are selecting downtrodden population, you are trying to study the health of the marginalized communities. So you must try to stock yourselves on the marginalized populations, not the whole populations. So your population will be the based on your objectives, which kind of population you are trying to study. So then you basically give the number of the particular village population and select sample like 5%, 10%. So it depends on the researcher that how he is. So scientific approach. Basically, this sampling, probability sampling, is basically is a very scientific. Like we can attach this with the positivism. You can talked about here, very scientific kind of approach. When we have certain kind of qualitative kind of data or qualitative kind of research topic, so at that time we use probability sampling and different types. So follow a verifiable process. It is the best approach when total accuracy is not mandatory, or even when the domain unit share homogeneity. So again, I'm telling to you that homogeneity is very important when you're selecting any kind of things. If you're selecting the state vendor women, you select each and every women who have state vendors. Not beside that. If you're selecting anything beside that, it means that you are going unscientific. Okay. So do you understand me? Please, can anybody tell me? I'm clear.
Yes, sir, you are.
Okay, okay. Thank you. Thank you. So here is basically when we classify the sampling, we have basically two kind of sampling techniques. One is probability sampling and another is non-probability sampling. So non-probability sampling is not my topic today. So I am going with probability sampling, which is very important while you are studying a very large kind of data, large kind of population. While when you are trying to quantify the population, and this context, you go to this kind of probability sampling. So one thing very carefully, that probability sampling, we are using probability sampling when the population is very known. And I'm just giving a little comparison because we can't go with the probability sampling, but yes, we have select this topic because we can't go along with probability sampling until and unless we have a little bit comparison and knowledge about the non-probability sampling. Probability sampling, so just remember one thing, like probability sampling, we are using in a very quantitative kind of data where population is known, and non-probability kind of sampling when we use particularly in qualitative kind of data where population is unknown. Okay, this keep or remember only this difference. So in probability kind of sampling, we have five kind of sampling: sample, random sampling, systematic sampling, stratified sampling, cluster sampling, and multi-stage sampling. So in next slide, I try my best to basically talk one by one on the sampling. So what is probability sampling basically? So I have already told you that removing bias one random choice at a time. So if you are selecting any kind of population, so if you want to remove the biasness, you must go to the probability sampling where you can quantify the population like 1, 2, 3, 1, 2, 3, 4. Just I'm giving you an example. I'm in a sitting, suppose I am sitting in a classroom and I just want to try that how many students are coming late. So if I'm those people who come late in my class, because some people are coming late, I'm just go away. Why you are coming late? Go. So I'm not talking about their I'm not consider their reason why they are coming late. So suppose if I'm consider their reason why they are coming late, so I become biased. Sometimes some students maybe say me that, sir, we coming late because we have some issues. There was a jam in the road and there are landslides. My mom is alone at my home. I help her, and give certain kind of excuses which may make me emotional and just, oh, okay, come in. So instead of going to the reason, I just go without reason, just go objectivity. So probability sampling is going with objectivity, where you just try to objectify the concepts or units. So, and one thing is you remember very carefully that probability sampling is not applicable for all kind of research. Probability sampling is not applicable for all kind of research, but it particularly concerned with the quantitative kind of research. So we use probability sampling when our goal and our objective is to quantify the population, to quantify to survey kind of research, census kind of research. So we try to use probability sampling, not non-probability sampling. So the first type we have actually tried to explain here. You will find here sample random sampling. So here is the name. Actually, you will find one row, second row, third row, and fourth row. So what is basically the sample random sampling? The foundation of randomization, we can say that. every single individual in the target population, like street vendor women or the food habit of students in university or colleges, these are our target population, has exactly equal independent and non chance of being selected. So we can call it randomizations. Like how we can say what are the mechanism through which we can select. Researchers use random number generator or lottery system to pick subject blindly. Like what we actually do sometime. Suppose we have 15 or 20 student in our class. So I just want to try that what is the attitude of students toward the teacher. So I just try to select the randomly. So when we talking about the sample random sampling, one thing every time we actually studied and read it, every individual or every unit gave equal chance of being selection. Why we are have actually saying this kind of things? What it means actually? What it means, every chance of given every unit equal chance of being selection. What does it mean and how we can operationalize this? How we can understand this sentence? We have 14 or 15 students in our class. So we just try to know the students' attitudes toward the teacher. So we just make cautious all 14 students. I am going to ask you one question. What questions the students may ask that, sir, what is the questions? So everybody is be attentive. Sir, mujhe puchenge, sir, mujhe puchenge, sir, mujhe puchenge. Because I am not selecting anybody else. I am already told my students that I will ask anybody, not select first or third. You are getting or not? What exactly I am doing? So all the 14 students for that particular time of period get much conscious. Sir, mujhe puchenge, sir, mujhe puchenge, sir, mujhe puchenge. So I am giving everybody have equal chance, and their mind is prepared. Like sir, mujhe puchenge, sir, mujhe puchenge. Then I took a random students in the front row, like one student and two student, which represent our first row. But while selecting the two students, we select like if we selecting male or if we selecting female. Like if we selecting one male, then we must select one female. Here we actually try to make a proportionate kind of sampling, like equal kind of sampling. So we select like first row in two students from first row. Then in the next row we have 1, 2, 3, 4, 5, 6, 7, 8 students, and I'm just going to the second row and 8 students are getting ready. No one knows that whom turn is basically who actually whom sir actually will ask. So I'm just asked. Then this in first row I am asked third person, and the last, and in the second row I must took any random persons. Similarly, when you selecting any kind of study area, you must actually try to randomly make selection, but the population must be homogeneous, representative, and must be very unbiased, which actually I am giving earlier slide a very ideal kind of example. So for example, a corporation wants to survey its 100 employees. A student, we can take the example, and HR, the human resource persons, actually inputs all thousands IDs number into a computer algorithm, which purely randomly selected 100 out of these 100 IDs. So like similarly, I'm just giving you an example here. So similarly, if you are studying any rural village, any city, you must aware that the population must be known, must be identical. You have a proper calculation of the population through which you can select the sample. If you don't have population, known population, then you can't go ahead, because random sampling means you have known populations. Non-probability sampling means in non-probability sampling, we have snowball sampling, we have purposive sampling, we have convenience sampling. We use such kind of sampling where population is not known. So, but when you use probability sampling, it means your population is known, your population is in numbers, and you just try to make certain kind of random selection. So the for best highly uniform population where you have a complete accurate master list of everyone. So I have told you that you need to prepare a very solid kind of list of your village, of your target populations. So based on this, you can just sample size. So the next sampling is systematic sampling, which is very important, and people sometimes not in use in a proper way. Like when you use any kind of methodology, which is very important for any kind of research, thesis, research papers, and particularly when you are going to publish in a very high reputed journals, nobody can actually care about your paper if your methodology is not correct. So before going to actually publish, or before going to make your writing your thesis, your research paper, must try to make a consistency between or among the methodological concepts, like what is your theoretical perspective, which kind of sampling, which kind of design you are going to use. So these kind of things comes when you study and when you must make certain kind of links between the methodological concepts or steps. So the next sampling is systematic sampling. So what is systematic sampling? Basically, it's a little bit unique and a little bit different from the random sampling. In random sampling, you don't need to make any kind of systematic kind of number. You just have 1500 population. You don't need to be give 1 2 3 4 5 6 7 8 and 500 1500 populations. Instead of that, you just have 500 population, and out of 500 you just choose 5%. That's it. But in systematic kind of sampling, you need a much conscious, much awareness about this. How you can actually select the population while using systematic sampling. So systematic sampling we also called interval approach. So here you can actually select subjects selected from ordered list at regular mathematically calculated intervals starting from a random point. What does it mean? Like you have to make a list like 1 2 3 4 5 6 7. Like I am just showing here 1 2 3 4 5 6 and so on. So you have to give a proper number. You have make this population mathematically in a way, and in a very calculated intervals. And after that, what is the mechanism of for this sampling? Calculate the interval which denotes k is equal to population plus upon sample size. This is the formula you must remember while you are using systematic sampling. But mostly people are using cluster sampling, stratified sampling, and sample random sampling in qualitative research. But you must understand this sampling also. It's very important. So pick random start between 1 and k. K is your interval. Then pick every kth, yani ninth or kth. Kth means the number which you get from this calculation. Just I will, in next slide, I will show you how you pick the numbers and how you calculate. For example, I'm just giving you example. A clinic want to survey patient satisfactions. They randomly start at patients 3. Like randomly, first number. You have your own choice. Like first number, you can select. Like 1, you can select 1, you can select 2, you can select 3. First number must be randomized. And then after that, you must follow the calculated number. What is the calculated number? I will just tell you. Suppose randomly start at patient number 3, and then survey every 5th patient who walked through the door. Like first he select third patient, then after that 3rd plus 5 is equal to 8. Then he select 8th. Okay, then 8 plus 5. Then like that, you just going ahead and selecting the sample until and unless you have completed your sample size which you have chosen and you which you want to go to select. So Kash, what is the actually we must cautious about? So ensure there are no hidden pattern in your list. For example, every fifth house is a corner house. Like if you are selecting, like we have a lane, and in the lane we have 15 household, 15 houses, and we must select on the 30 house. What we can do, we give the number 1 2 3 4 5 6 7 8 9, and after that pick up the third household, then after that fifth household, then fifth, then eighth, 13th, then 19th, 18th, then like that, and until and unless we have completed our sample 30. So how we can actually calculate this? This is the calculation you actually try to understand. Systematic sampling. Here is the components and formula. K, sampling interval, distance between selection. K is equal to N. The capital N denotes your population and the small n denotes your sample random selection or sample size. Like here I am just giving you some example. Like N define population, here step by step procedure, and determine sample size N small, and the calculation interval K is equal to N upon small n. So R is equal to pick number 1 to K. K, we actually try here what is the K. So suppose you have N, like I am audible. Is my screen visible, please? So K is equal to capital 9 upon capital N is equal to small n. It means we have total population. K is equal to, what is our total population? 2, like here, you will find here, 2000. Our population is 2000 and your population may be 3000, 5000, 10,000, 10 lakh, 10 crore. Then you must follow the same. And we want to actually select only 5%, or we want to select only 10%. We want to, what is the 5% and 10%? We want to select like 200 out of total population. So what we can do, we just divide 2000 upon by 200. So is equal to, we get 10. Okay, we get 10. So it means that we actually select every 10th. It means K is equal to 10. And in your sample size, when you increase your sample size, when you increase your sample, and it will be vary. You are getting me or not? So what we can do, suppose. So first thing you must remember. So if we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 15, and like so forth and so on. So what you can do first, remember one thing, you have to choose under first random number which will be under 10th number. Like 1 से 10 तक, the first 1 से 10 तक, you have to select first random as per your own choice. Like I'm showing you here, 1K. So K is 10. Or K is 10 and 1. 1 is this. So under 1 से 10 तक आपको कोई सा भी नंबर randomly select करना है. So like 1 से 6 तक कोई भी randomly select करना है, 10 तक कोई भी आपको randomly select करना होगा. तो suppose हमने क्या select करा? We have selected 6. The first our random selection is 6, and after 6, and how much number actually we want to select? from 2000, how much? 200. Yeah. So 200 we actually try to select from 2000. So how we select? First we have select 6. Then after select 6, we add, we plus, we jump 10th number. Here is the 10th. So because we n k is 10th for us, so we select every 10th after 6. So 10, 6, 7, 8, 9, 10, 6 plus 9 plus 10. How much? 16. It means one sample or two sample. And after what I should say, 16 plus 10. 16 plus 10. 16 plus 10. 26. 26. It means third sample. So 36. 26 plus 10. 36. 36 plus 10. 46. 46 plus 10. 56. So 1, 2, 3, 4, 5, 6. So until and unless we get this number 200, we actually going through this process. You're getting me? So this is basically called the systematic sampling. And this is the formula through which you can understand the systematic sampling. The third sampling is stratified sampling. What exactly is the stratified sampling means? The first sampling, we are going to use sample random sampling. And the second is systematic sampling. Both sampling have a little bit different kind of procedure and selection procedure. But when we're talking about stratified sampling, it also has a very different kind of selection process. But here we also use sample random sampling. How? I will discuss here. So guaranteeing proportional representations, we can actually understand in stratified kind of sampling, we must understand that we select a very proportional kind of sample. Like if we select 10%, if we select girls, we must select boys. If we select old men, we must select young. If we select like drug addictors, we must select both female, male, and just try to study. So what is stratified sampling basically? In stratified kind of sampling, the population is divided into subgroups which we call stratas based on the shared trait. So like I'm giving you example like again I'm giving you example like in Rajasthan you are selecting some women's, but divide the women like men and women. Like if you are studying in this kind of sampling, first you divide like street vendors men and street vendors women. Both have same kind of occupations, where you just try to make a variance, where you just to make a compare that which kind of group is going toward high accumulation of wealth or high what I should say like income. So we can make based on stratas. So based on shared traits, sample are then drawn randomly from within each subgroups. What is the mechanism here? Mechanism is identify some stratas like age, income, occupation, we can say that, gender, we can say that, and determine their percentage in populations. So we can determine what are the presentation. Like suppose if we take the example of like how many OBCs are in higher educations and how many generals are in higher educations. Suppose you will find 60% people who are from general category and occupied a very good kind of position in higher educations, and only 30% people have OBCs, and only 10% have like other castes. So but among those, we just try to basically make a clear kind of percentage, clear kind of numerical data. Then after that, we just try to randomly make such a selection individually. Like then randomly sample that exact percentage from each group. Suppose a university is 60% undergraduate students, 30% masters, and 10% PhD. Because PhD is there is a very limited seats of PhD. There are very not like masters and UG seats. So we have only 10% of PhD in a university. So to get a sample of 100, what we actually do, we randomly pick 60% graduates, like 60 graduates, 30 master students, and 10 PhD students. Like in every kind of strata, we just take into consideration and select as per their population. We select, randomly from each and every group. So best for best use, ensure minority or smaller group are not accidentally left out the final sample. Suppose we can say that here are in PhD we have only 2 students, so left we don't need to be take into consideration these 2 students. But no, you can't do this, because if you are studying any university students, so if your goal is to study the entire university students, you must include these. If they are 2, you must select 1, because the one which represent the other one, the one which represent the other 3, and here the 2 which represent the 60% means 2 which represent these 6. So here you will find this is the whole population, and you just make first strata like blue color, parrot color, purple, and gray color. And out of this, you randomly select like 4 is for women, for old persons, 4 are farmers, and 4 are like other persons. You just select each and every kind from each and every groups as per their percentage. So the next is basically stratified sampling, cluster sampling. So what in next slide, I'm just trying to basically make a comparison between the cluster sampling and stratified sampling, because these 2 sampling sometimes create very much confusion. So be careful here. When I am talking about stratified sampling, in stratified sampling, what you are doing, you make certain kind of stratas, like stratas, and in stratas you make certain kind of groups, and in after these groups you just pick 1 or 2 individuals, not the whole strata, but only 1 individual. It means you are, after making stratas, you further choose individual from the strata. It means you are using sample random sampling after making some stratas. So, but in cluster sampling, it's not like that. What are exactly cluster sampling? Sampling by geography are natural boundaries. When your sample size is very broad, or when you are going to select a whole kind of nations, whole kind of countries, states. So in such circumstances, there is a good call if you use this. There is a good call for choose the cluster sampling. So what is cluster sampling? In cluster sampling, the population is divided into diverse groups, or we can say clusters, like I am using here. This is one cluster number 1, this is cluster number 2, this is cluster number 3, and this is cluster number 4. But one thing you must remember, that all the cluster must be homogeneous. Like we just try to study the medical colleges of India. What exactly the medical colleges contribute toward the Indian society. So first, this is the whole actually Indian college. Suppose every state, like we make 4 zone, like north zone, north, west, east, and like middle zone. Okay, and in 4 zones we just select certain kind of colleges here. So what we can do first, so first we divide the internally diverse groups, clusters, instead of sampling individuals. researcher randomly select entire clusters. Okay, you are getting me. So how? Because what is the mechanism of selecting the entire clusters? Like divide map population into clusters, then randomly select a few clusters, survey every or randomly subset within chosen clusters. What exactly then we are going to do here? Like after this making certain kind of clusters in stratified sampling, we make first one strata, two strata, and after making stratas, if you remember, we just pick one individual from the here or two individual from the here and two individual from here. But in cluster sampling we are not going to do that. What we are making four clusters, and out of four cluster we choose one minute. Sorry. So we choose from one cluster from here and one cluster from here. And after selecting the clusters, we are not going to pick the one college here and one college here, but we are going to study the entire cluster. We are going to study the entire cluster from here. All the clusters we actually have included in this. Like if we are going to study the entire medical colleges of India, and first we divide north zone, south zone, east zone, and west zone, and we actually include every colleges in particular zones. And after that, suppose we make 3 or 4 colleges in north zone, in west zone, in south zone, and east zone. And what actually we are going to do, we select one zone from north and one zone from west, and after selecting these two clusters, we study entire clusters. Like if we select suppose three government medical colleges actually fall in this zone, and we actually try to study the entire kind of students in that particular zone, not going to further taking the individual sample. Okay, so suppose I'm just giving you here an example. An NGO wants to assess reading level in massive state. They divide the state into 50 what I should say clusters. So after that, they randomly pick 4 quantities. They randomly pick 4 clusters, test every school child in those 4 clusters. So what exactly, you can't make further sampling, but instead of that, you have to go and make research, try to examine the entire clusters instead of going to further sampling. So the best for this, VAST, where we can use, where is this sampling is basically very helpful. Where is vast population, geographically dispersed population, where travel, logistic, and cost are prohibitive. So in such kind of circumstances, we can use cluster sampling. And the last sampling we actually have in probability sampling is like multi-stage sampling. So what exactly we are going to do in multi-stage sampling? When population are exceptionally large, researchers combine techniques, stepping down through multi-level of randomization to reach the final sample. What we can do first, suppose when we try to study like when we try to study the medical colleges through this multi-stage sampling, first what we can do, make a large clusters. Like start with broadest geographical or organizational boundary, randomly select a few large entities. Example, randomly select 5 states out of 50. Like we have 28 states. How we can actually select while we are using multi-stage sampling? First we have 28 states and union territories. So what we can do, first select 2 states out of 28 states, select 2 states, like we are selecting 1 state from northeast, 1 state from south, 2 or 3 states. And after selecting 2 or 3 states, we just select in second stage, what we can you do after this, choose some states and list all their cities, randomly select subset of cities within them. Like after selecting 3 or 4 states, we just select some cities or some villages. And after selecting the village in third stage, after selecting the village or cities, we just select household. You go further down in cities, you just select to the towns. In towns, you just select to the municipalities. And in municipalities, you just try to select the household. And in rural aspects, you just try to panchayats, blocks. Then after blocks, you can select, go to the tehsils. After tehsils, tehsil, you just go to the household. And after that, you can go and select the individual as a sample, where you just try to understand. So you select all these things as per your objective. So keep one thing in your mind, that probability sampling is particularly used quantitative kind of research. We never use probability sampling in qualitative, but in quantitative kind of, where we try to quantify the object or population. So when we try to compare these sampling, how we can just to try basically how we use and what are the core concepts when to use it, and primary challenges. What are the primary challenges? So first is random sampling. What is random sampling? Where we pure chance of selection, like lottery method. You can use drum method also. Lottery method, like write some things on the tickets and the slips. Then you can choose, take any child like. So ask them, then pick anything. So among the many chips. So slips. So this is one thing you can use in sample random sampling. So when it to use it, when you have a complete accurate list of highly concentrated populations, when you have known population, when you know that what is your exact population, so you can use this method here. So what are the important primary challenges while you are using this kind of sampling? So impractical for massive geographically dispersed population without master list. So it is very challengeable when you don't have the list of that particular population. Suppose if you are going to study a chronic patient in hospitals, so how you can actually select the patients if you don't have the list of the total inpatient in that particular hospital? So you must have list. Then after that, you can decide that what kind of percentage I will select and what kind of sample I just want to select. So another is systematic sampling. What is this? Select every ninth and ninth number. I just told you earlier that what is the the formula. K is equal to capital N upon small n. So when observing a continuous flow, for example, assembly lines, clinic, waiting rooms, so such kind of circumstances help when you try to study. So here you can use systematic sampling. So what are the challenges here? Risk of bias if the population list has hidden or recurring pattern. So suppose you have some kind of, you have list, but you can't actually have in a very proper way. So it create a big challenge for you. So stratified sampling, proportional selection from subgroups like 2 male, 2 female, 2 old age, 2 poor, 2 rich. So like this, you have to select. So when you must guarantee exact representation of minority group like gender, income, age, so you actually take into consideration all these variables while using stratified sampling. So require precise prior statistical knowledge of population demography. So in this context, you have to particular prior statistical knowledge. So how you can get this statistical knowledge? You make certain kind of literature review. So making literature review actually help you to design certain kind of hypothesis. And after making the hypothesis, this probability sampling helps you to operationalize your objectives, your research questions, and your hypothesis. And hypothesis, the main source of hypothesis basically is literature review. Okay, so Cluster sampling, the main core concept is selecting entire geographical group, which I have already told you. When the population is vast, dispersed, and individual travel access too costly, like the entire India example I'm giving to you. Okay, so what are the risks here? Higher margin of error if clusters are not internally diverse. So here is very higher margin of error if there will be a very clusters are not particularly identified or cluster are not internally diverse. So maybe your research going to toward unscientific way if you are not basically taking into consideration the exact feature of ideal sampling. Okay, so then what are the directions we can use? What are the sampling and what are the methodological steps you will use and a researcher will use when he or she has planned to use the sampling or probability sampling, like where sampling fit in the research process. First, like your research questions is very important. So your research, it's depend wholly and solely. Every kind of research methodology, every kind of methods, every kind of tools, every kind of research design is depend on your research objectives and research questions. Suppose identifying the core problems, what are you trying to prove or discover about the population? It's very important. And based on this, determine the overall approach. Like your research is going toward quantitative or survey-based, clinical trial, or cross-sectional. So if your research is going toward qualitative, quantitative, survey-based, trial-based, or cross-sectional, so it means that the best fitted sampling is probability sampling. And in probability sampling, you have four kind of sampling. Each and every kind of sampling you can use among these 4 or 5. So define the target population. So sometime what are actually scholars do? They are what actually scholars do. Basically, they don't know what is the target population. They are selecting like some people, many villages, but don't know what exactly they want to do. So there are two settings where you can select the population. Suppose we have target population, and after that, where you actually approach the target population. Like we have two settings. One is natural setting and another is semi-natural setting. Natural setting, I'm just giving you an example. Like if I am want to try to study the chronic patients of hospital. So our target population's natural setting is hospital, because patients we will find patient in the hospital, not in the market or in the shop. And similarly, if you try to scrutinize the shopkeeper's behavior toward the clients, so where you will, the natural setting of the shopkeeper is the shop. You are getting me or not? So try to basically operationalize and understand the concepts very minorly of when you try to study and use any kind of sampling. So define the target population, choose the exact probability method, like sampling method you want to use, stratified sampling to use, because to ensure the validity of your population. So data collection and analysis, execute the sample selection, gather the hard data. It means collected data, numerical data, like the statistical data, use statics to info back to the population. So how you used and how the population you have actually used, how the sample denotes or represent your entire populations. So you can actually, when you use these kind of steps, it will very helpful for you. And because along with this, these kind of things help you in making your paper, making your thesis a very fruitful direction. Thank you.
Your presentation was interesting, and it has covered the questions that we received.
Okay.
But as a part of the official ceremony, I would like to extend a vote of thanks. So
Okay.
I express my sincere gratitude to our esteemed speaker for delivering an insightful and intellectually enriching session. Your explanation of importance and need of sampling, relating it with principles from everyday biology and how physicians take a sample of blood from our body to test infections, and those topics. The principles explaining practical explanation and application of probability sampling has enhanced our understanding of research methodology and statistical investigation. The clarity with which simple random sampling, systematic sampling, stratified sampling, clustered sampling, and multi-stage sampling were presented made the session highly engaging and informative. I would also like to extend my heartfelt thanks to Mr. Vishnu Rangawat, founder of Council for Advocacy and Policy Research, Rajasthan, for organizing this valuable meeting and creating a platform for academic discussions and learning. Special word of thanks to the technical team and for their hard work and behind the scenes, ensuring the smooth conduct of this program. Finally, everyone present here, the scholars, the academic community, for your valuable time, attention, and participation. We hope we continue running these sessions and can bring some valuable contribution to our scholarly community. With this, I conclude the vote of thanks. Thank you and have a great weekend ahead.